Hi everyone, my name is Amelia McCutcheon. I'm from the Zen of Chemistry. Today I've got a little bit of a different thing to talk to you about today. I've had a request from a student to talk a little bit about spectroscopy and do a video about spectroscopy, and I'm just finalising the lecture slides for my next round of free resources. So if you'd like to get access to them, please sign up at my website at zenofchemistry.com. So I'm just going to talk really briefly about what spectroscopy is, because people hear the word spectroscopy or spectrophotometry and they go, wow, that word sounds really complex. And in fact, you know, it is a complex process, but it doesn't need to be made complex in terms of the way you learn it. So the way I like to think about spectroscopy is that it essentially is the interaction of light with matter. And so depending on what wavelength of light you've got, so you could have visible light that we can see, so there's red, orange, yellow, green, blue. There's UV light, which of course sometimes gives us sunburn, hopefully. And then we've got things like infrared light. We've got so then we start talking about it being radiation, but we've got X-rays and radio waves and that kind of thing. So depending on the wavelength of light will depend on what part of the molecule or atom that light interacts with. I've kind of got a bit of a simplistic view of this, and this is why I want to distill it down into something nice and simple so that you can grasp the idea and then take it from there with your understanding. So what I've got for you is I've just got a glass of blue cordial, and essentially when we look at the blue cordial, the light that we can see is actually interacting with the molecules in this blue cordial. So when you consider spectroscopy, I like to think about it in three components. So I'll come back to the cordial in a minute. You know, you've got three components in a spectrometer. They're all different. Spectrometers are going to be different, and they all do different things. But essentially you've got a light source, or a source of electromagnetic radiation. You've also got a place where you put your sample, and that's where the light interacts with your sample. And then you've got your detector, and that's as simple as it needs to be: light source, sample, detector. Okay, and so depending on the type of spectroscopy, you've got different ways in which you measure the light at the from the source of light to the detector. So if we consider our cordial, I'm going to consider my source of light the sun. I've got the sun coming through my window here, okay, and then our sample is our cordial, and then the detector is my eyes. So when I think about the type of light that's coming from the sun, I'm not going to really consider the UV light or any of the other types of electromagnetic radiation, but I'm going to consider the different colors. So I'm going to consider red, orange, yellow, green, blue. We might leave it with just those colors. But if you consider that white light from the sun is made up of all of those colors, red, orange, yellow, green, blue, okay, when that white light interacts with my blue cordial, okay, we have two terms. We've got some of the light gets absorbed by the blue cordial, and then some of it gets transmitted. In other words, it reaches my eyes and I can see the blue color from that white light. So when I consider all of those colors, red, orange, yellow, green, blue, okay, the colors that are reaching my eyes and being able to get to my eyes so I can register that it's blue light is actually the blue light. Okay, so out of all of those red, orange, yellow, green, blue colors, the blue color is the one that's getting to my eyes. So we would say that blue light is being transmitted in other words, it's getting through to my eyes, and then all of those other colors are being absorbed. Okay, so the red, the orange, the yellow, the green are being absorbed. You might get a little bit of green coming through, but definitely the blue is transmitted. So when we're talking about spectroscopy, we're often looking at, well, you know, there's different types of spectroscopy, as I've said. Sometimes you're looking at the emission of light from your sample, and sometimes you're looking at the absorption. Most of the types of spectroscopy that you look at in VCE are definitely where you have light absorbed. So based on what you've got in your sample, what the type of light you've got, you can actually work out how much is in there. So for spectroscopies like UV visible spectroscopy and atomic absorption spectroscopy, it's a quantitative analysis. So you're working out how much of your sample you've got in there. Things like nuclear magnetic resonance spectroscopy, or NMR, and infrared IR spectroscopy, they're more geared towards working out what you've got in your sample according to how that light interacts with your sample. So with my cordial example, I'm going to just really zone in on the UV visible and the atomic absorption spectroscopy. If you consider cordial, you know, I've got a medium darkness cordial here, but if you can consider that, you know, when you buy it in the bottle, it's quite dark, and then when you make up your cordial, it gets lighter, and you've diluted it, right? So essentially, when we have the cordial in the bottle, okay, less light, so it appears darker because less light is getting to your eyes. And so when you have lighter cordial, you more of the white light is getting to your eyes. So it works the same way in spectroscopy. When you're looking at absorption of light, the more analyte that you have, the more absorption that you have. So that's in the case of atomic absorption and UV visible analysis. So we can use that information, how much light is getting to the detector, by actually comparing the absorbance or the transmittance of known standards to whatever you're trying to look at. So if let's say you're trying to find out the calcium content of a solution, you would make up, so this is for atomic absorption spectroscopy, you would make up known concentrations of standards of calcium. You would find out the absorbance of those different concentrations, and then you would actually analyze your sample and use a straight line graph to extrapolate back and find out how much of your sample you've got how much calcium you've got in your sample. So that's just a quick, very, very quick little introduction to spectroscopy. At the end of the day, at the end of this video, I want you to walk away with the idea that spectroscopy involves the interaction of light with matter. And depending on what that wavelength of light will depend on how it interacts with the matter and what kind of information that you can get out of that. So I hope this has been helpful. I hope this is something that you can sort of start to get your head around what spectroscopy is. If you've got any comments, please leave them in below this video here if you're watching this, or if you're watching now. If you liked this video, please give it a like. I like a little bit of feedback to know that people are getting something out of this, so please do. If you'd like to check out my YouTube channel, it's just the Zen of Chemistry, and I've been posting up worked examples from VCAR, past exams questions, so they're all 100% free. This is 100% free, and if you're really interested in what I'm doing, I'm giving away a lot of my knowledge for free through my mailing list. So if you like what you see, some of my lecture material is available for short periods of time, so you can sign up at my website. and get those. So I hope you found this useful. Thanks very much for joining me. For those who've viewed this while I've been on, I realize I'm doing these during school hours, and I do apologize, but I'm not able to do it very often after school hours. So hopefully you can watch this after school and get some use out of this. And please share this information around. I hope to be able to reach I hope to reach at least 1,000 people this year and help 1,000 people. So hopefully by doing these videos, I hope to be able to do that. So thanks very much for joining me. If you've got any more topics that you'd like me to cover, please send me a message or leave a comment, and I'll try my best to do that. Thanks very much.